Hello everyone, welcome back to Mr. Lee's Math Class Videos. I'm Mr. Lee. Today we're looking at the beginning of Chapter 7 in Math 1316 Trigonometry. To me, Chapter 7 is primarily about how trig functions work in equations and how they interact with algebra, or how the two worlds interact with each other. Think about when you learn arithmetic and you learn algebra and you learn how those two play together. Now we've learned the basics of trig. Now we're looking at how it interacts in equations and algebra. So first things first, there are a few things that we need to cover. There's a little explanation up here that I'm not super worried about. There's things you have to know when doing these. The reciprocal identities, for example, cosecant is 1 over sine. Secant is 1 over cosine, and cotangent of an angle is 1 over tangent of that angle. And the same is true the other way. Sine theta, just by looking at moving the equations around, is 1 over cosecant theta. And the same for cosine and secant. By multiplying one to the other side and dividing it over, you get really all of them have an equivalent reciprocal identity with the corresponding trig function that has always been its reciprocal. Additionally, the quotient identities, tangent theta is equal to sine theta over cosine theta, and cotangent theta being the reciprocal also takes that fraction and flips it. Pythagorean identities, sine squared theta plus cosine squared theta equals 1. This is probably the big one. It doesn't matter what angle's in here. It could be theta, it could be 7 theta, as long as those two match, and it's sine and cosine squared. This is true. The other thing that's important to note is sine squared theta equals 1 minus cosine squared theta. By subtracting the cosine squared theta to the other side, similarly, cosine squared theta equals 1 minus sine squared theta. Being able to algebraically manipulate these equations is really helpful. There are equivalent ones for tangent and secant, cotangent and cosecant. They can be derived from the original Pythagorean identity. And if you think about it, this one is a 1 where there was a cosine squared. So if you divide everything by cosine squared, you get the second one. If you divide everything by sine squared, you'll get the third one. And much like the original one, these can be moved around appropriately to isolate different pieces of that equation. The even and odd identities don't come in nearly as often. One thing to note is that cosine and secant are both even, which means if you have a negative angle on the inside, you can remove it without changing the outcome. Sine, cosecant, tangent, and cotangent are all odd, which means you can move the negative out, but it has to be accounted for in some way. So 7.1 is really focused on practicing using the identities, these algebraic ways, and not using triangles to solve questions. So if it tells you to use identities, it wants you to find them practicing using some of these equations to solve for the other ones. So let's go ahead and look at some of these on the next page. And this is something that you really have to practice. There's no substitute for you practicing and being familiar working with them. So find sine theta given cosine theta equals 5/13 and theta is in quadrant 1. So when you're looking at what you're given and what you're trying to find, you're really looking for an identity that has both of these in there in some way and nothing else, because you don't have anything else. So if you recognize that sine squared theta plus cosine squared theta equals 1, and that helps with what you've got, you can write the identity down, sine squared theta plus cosine squared theta equals 1, and substitute in what you know. You know that cosine theta is 5/13. So as a reminder for how this works, cosine squared theta is really cosine of theta whole thing squared. And that's just how they write it to let you know that it's the cosine that's squared and not what's inside that's squared. Which means sine squared theta plus, we know cosine theta is 5/13 squared equals 1. When you square that, sine squared theta plus, this is 25 over 169 equals 1. Our goal is to solve for sine of theta, which means I have to move the 25 169ths to the other side to get that sine squared theta equals 1 minus 25 169ths is really 169 over 169 minus 25, which is 144 over 169. Now, again, just like cosine squared theta was cosine theta squared, sine squared theta is really sine of theta squared. It's 144 over 169. And this is the part where to get sine by itself, it's currently squared, you take the square root on both sides, which you do in the distance formula often, to get that sine theta is now plus or minus 12/13, because you don't really know if sine theta was positive or negative. You do know that when it gets squared, it becomes positive, so that when you take the square root, you have to acknowledge it could be either one. Now, this is where the little info about your quadrant comes into play. Here you know sine is positive and cosine is positive, but more importantly, you know sine is positive. So if this angle is in the first quadrant and you're trying to determine if sine is positive or negative, that quadrant will tell you that sine has to be positive. So that tells you, because sine is greater than 0, that sine theta has to be the positive 12/13 and not the negative 12/13. There is another place where that cosine value produces a sign that's negative, but that's in quadrant 4, where cosine is positive and sine is negative, and that is the big difference here and why they have to tell you something about the angle in some way. Otherwise, you would have been multiple options. So we'll do B, and then I'll leave C for you to do. So B says sine of alpha, find sine of alpha given cosine of negative alpha is 4 square roots 17 over 17. This is a little bit where that even property will come in. We know that cosine, you can get rid of the negative in the angle and it doesn't actually change anything, and you really need these two things to match. Now, tangent is positive. So we know cosine is positive and tangent is positive, and since tangent is sine over cosine, in order to divide these two things, if one of them is positive and the outcome is positive, the other one also has to be positive. So this is really telling you that sine of alpha is also positive for the same reason we needed to know up here. But otherwise, it's the same strategy, sine squared theta plus cosine squared theta equals 1, which also means sine squared alpha plus cosine squared alpha, which in this case is the 4 square root of 17 over 17 squared, is 1. As long as those angles match, this will be true. From here, you'll square 4 squared is 17, this is 16 times 17, because 4 squared is 16, square root of 17 squared is 17. And down here it's 17 squared, which is really 17 times 17, and I'm going to write it like this for reasons. Here you'll see a pair of 17s should cancel, so that means sine squared alpha plus 16 17ths equals 1. Subtract the 16 17ths, sine squared alpha equals 1 17th, because this will be 17 over 17 minus 16 over 17 to get 1 over 17. Just like before, we'll take the square root to get that sine of alpha equals plus or minus 1 over the square root of 17. And if you rationalize that, that's square root of 17 over 17. Now we said we know that sine is positive, so between the positive and negative here, you know that sine of alpha equals just regular square root of 17 over 17. I won't care if you leave it like this, but you know that the homework will, so make sure to rationalize. C is very similar. The only thing that you really have to do is change, if secant beta is 7/6, then cosine beta is 6/7, and you can go from there, keeping in mind that tangent is negative, and since cosine is positive, that will influence the sign of sine, which is weird to say. But that's all for this video, and we'll continue in the next video.